All right. Substitution rule. Because it rules. I love the substitution rule. This one is so amazing. This, I tell you all the time when you get into Calc 2, is that this is our go-to method for integration. Of course, if you have a polynomial, then that's super easy and you go with that. But is everything we're ever going to have a sweet little polynomial that I can use the power rule on? No. Right? That's a big no. Okay, so the substitution rule we typically call a U sub. All right? We're just going to jump right into this and just start practicing. So here's example 1a. I'm going to integrate 2 times this 2x plus 1 cubed dx. Now here's the deal whenever it comes to the substitution rule. We are going to do a U sub. So typically it's called do a U sub. That's a substitution rule. A U sub is typically the inside function. Now I'm just going to say the inside. Or I like to call it the what looks weird. Crazy or weird. All right? That's what you're going to go for on your U sub. So it's the inside function, something that looks crazy or weird. Okay? So I have an inside function right here, don't we? Blah, blah, blah. So that is what we're going to make our U. So U are going to come off to the side whenever I have this U substitution here. And it comes off to the side. And I'm going to make my U equal to a 2x plus 1. Then you have a du. So what we are doing with a U sub is we're taking something that I cannot integrate. Now, can you technically go through, multiply this out 3 times and work it? Yes. Technically you can, but, right? So then you take du. So here's our differential. Why it's so incredibly important to know how to do a differential. This variable's in x, so my differential's in x. The derivative of u is my differential here of du is equal to 2dx. So this is the derivative of u with respect to x. That's why when we practiced our differentials, I change the variables up on you all the time. Because du is the derivative of u, x here is dx. Ah, see? Sometimes I know what's going on. Now, this is a substitution. You are subbing this in. I am going to take the u and replace the 2x plus 1 with that u. I am going to take this 2dx and replace that with a du. I'm literally subbing this in. So I am now integrating u cubed du. Do you see what happened? 2x plus 1 becomes a u. That's what was cubed. And 2 dx, this 2 and this dx are now replaced by the du. Now I have a super easy integration here with this polynomial. You add 1 to it to get u to the 4th and bring the 1/4 in front, plus c. Now here's the kicker to the u sub. Anytime you do a u sub, you have to sub that back in because your final answer needs to be in the original variable. So my final answer here is a 1/4 2x plus 1 to the 4th plus c. All right? Okay, so here's the deal. The purpose of a u sub is to take something difficult to integrate taking something that's difficult to integrate and make it easy to integrate into a nice polynomial or something that is easy to work with. That's our sole purpose here of our u sub. Take something that's difficult and then we break that into something that's easy. How much room do I have? Not enough much, but we've got plenty, I think, for this next one. So here is example 1b. I'm going to integrate 2x times cosine x squared dx. So remember, what are we looking for? The inside function, the crazy thing. And sometimes you have to trial and error a little bit whenever it comes to your u sub. So trial that error, right? When I'm looking at something that is inside worthy, this x squared looks like an inside type function. So I'm going to try that out as my u. So my du here, what's the derivative of x squared? 2x. And don't forget that differential dx. I am taking the derivative of this u with respect to x. So that's where my differential comes in. And check it out. In order to do a u sub, you have to have something that can sub out. So now I have this 2x dx. That now becomes just du. So whenever I integrate this, I now have cosine u du, because this x squared goes in place of, or this u goes in place of that x squared, becomes a u. This du takes out the 2x dx. Literally just substituting. That's what's happening. Find the inside crazy thing, take the derivative of it, and then sub that part out. All right? What's the antiderivative of cosine? Sine. And then don't forget, if you start with an x, you have to end with an x. So I'm going to take this x squared and sub it back in. So my final answer here is a sine x squared plus c. All right? Practice, practice. We're going to practice, practice, practice. More practice. That's how you get good at these, is just practice them until you can't practice them anymore. All right. Let's do a couple more. Well, more than a couple. Basically, we're going to just practice a whole ton of these is what's getting ready to go down right now. All right. Here's example 2a. I have x to the 4th times the quantity x to the 5th plus 6 to the 9th dx. Yeah, I'm not multiplying that out. Anything to the 9th? No way. And because this is to the 9th, order of operations tells me my exponents come before multiplication. You cannot distribute that. You cannot. That is not mathematically correct. All right? So here's another little tip. When the degree on the outside is 1 less than the inside, that also indicates a u sub, right? Because when you take a derivative, what do? Subtract 1 from it, right? So the fact that this is a degree of 4 and the inside is a degree of 5, that tells me, ooh, this would be a good candidate for u sub. Okay, well, let's try this out then. If my u is that inside part, x to the 5th plus 6, then my du is taking the derivative of this. I have 5x to the 4th dx. Now check this out. I only have an x to the 4th dx. I don't have a 5 available to me. That's okay. That's okay. Because if I'm looking at, I'm going to take this x to the 4th dx right here, and this is the part that I have. That 5 is just a constant. If you just have a number that's going on there, let me change colors, then you can divide both sides by that number, and I actually have 1/5 du is going to get me x to the 4th dx, and I still have an x to the 4th dx. I'm just going to replace it with a 1/5 du. All right, if it's just a number, you can divide that number. Okay, now replace. I've got a 1/5, and it's a constant, so I'm going to chuck that bad boy in front. I've got a 1/5 here of u to the 9th du. All right. Taking something that is crazy and simplifying it and making it easy. That's our goal. So, oops, I know, too far. I just want to scoot it up a little bit. Now we integrate, so it's just a polynomial. So I'm going to add 1 to that. So I've got u to the 10th, and I'm going to bring the 1/10 in front, and I still have this 1/5 that I'm multiplying, plus c, because it's indefinite. If it were a definite integral, I'd have to put my bounds on there, right? But indefinite, we always have to put that plus c, okay? Then just clean it up. And I'm going to clean it up 2 times, 2 things at once. I've got this u that I'm going to plug back in at the same time I multiply those together. Now I am going to scoot this up a little bit. I've got 1/50th times, oops, too far, x to the 5th plus 6 to the 10th power plus c. All right. Taking something that's kind of crazy, oh, plenty of room. Taking something that's kind of crazy, doing a u sub, and breaking it down. Okay, practice. That's all I can tell you for these. The more you do, the more comfortable you're going to get with this. You have to know how to do a u sub. You just have to know. I don't know how else to say that. It just is what it is. Okay, guess what you can do this with also? Trig, baby. Cosine cubed of x times sine x dx. What's another way to write cosine cubed of x? Yep, cosine of x cubed sine of x dx. And what did we say about that u sub? It's the inside part. It's the crazy part. That's right. Check this out. If I'm looking at to do a u sub here, my inside is cosine. So let's try it. If u is equal to cosine of x, what is du? Negative sine x dx. Oh, check me out. Sine x dx, the only thing I have is this negative, and I'm just going to move it to the other side. So negative du is equal to sine of x dx, because I'm just dividing by that negative. And then I've got my sine of x dx. And, oh, wrong color. I meant to go black. Now I have u cubed du with the negative sign in front, because I just like to put mine all the way in front. Now it's much easier, right? Take something difficult, u sub that out. Okay, so now I have a negative 1/4 u to the 4th, right? Because you're adding 1 to that, so that's u to the 4th, bringing the 1/4 in front. And then, of course, plus c, because we can't forget that. And then put that back in. So a negative 1/4 cosine to the 4th of x plus c. Not too bad, right? Take something that is bigger and kind of crazier and do a u sub with it. Good. Make it to where it's easier to work with. Okay, good job. Practice.